Okay, so today's notes are on modeling with quadratics or with a quadratic. It's our first set on this section. We're going to have one more section of this. But our content objective for today is to use key features of a quadratic to write its equation. And our language objective is to write equations from application problems with quadratics. So again, quick refresher, forms of a quadratic are standard, vertex, and factored. So this is standard form, y equals ax squared plus bx plus c. Vertex form is y equals a parentheses x minus h squared plus k, and factored form is y equals a x minus p times x minus q. So we're going to be using these today, and like our objective states, we're going to try to figure out what key information is given in the problem, then select which form of our quadratic would be most helpful to start with, and then use that to write our equation. So identify key features from the problem, choose the most helpful quadratic form, and then write the equation given that information. So before I delve into our first example, the key features we should be paying attention to are the x-intercepts, because those will tell us our p and our q values. So if we know our x-intercepts, we know p and q. So if that's one key feature we should be looking out for, because that would help us figure out if we're using factored form. Our y-intercept, that can be helpful because that tells us c. So y-intercept is our c value in standard form. So if we know our y-intercept, that can be a helpful key point to know. Our vertex, obviously for vertex form, if we know our vertex, our maximum or minimum point, we know h and k, so we can use our vertex form if we know our vertex. And if we know other coordinates, then we will have to use that information at some point to figure out other components, because even if we know our y-intercept, or we know h and k, or we know p and q, we still will need to figure out a or b or other components, which we'll need other coordinates for. So you always need at least 2 points if you have your key bits. If you have key points, you still need at least 2 coordinates to figure out all of the information to write your equation. So let's delve into an example so you can see what I'm saying. So our first example, I don't want to scroll too far because I wrote the rest of the steps. It says Jason launched a model rocket from the ground. It hits the ground 7 seconds later and had reached a height of 2 feet after 1 second. One thing I want to note, it says it reached a height. It does not say it reached a maximum height, so you can't assume that that's the vertex. So before I go any further, even though it reached a height of 2 feet after 1 second, that does not necessarily mean it's the vertex or the maximum or minimum. In fact, it can't be, since we actually know it was launched at time 0 and hit 7 seconds later, so the maximum needs to be halfway between 0 and 7, so it'd be at 3.5. So we know that this point, the height of 2 feet after 1 second, is not going to be our vertex. But let's back up and figure out what information we do know. So what's helpful to start with is the list I have. So x-intercepts, we do know the x-intercepts. So it was launched from the ground. That means that it had a height of 0, and the time was also 0 because it had not gone anywhere yet. So our first step is to identify key features. X-intercepts are 0, 0, and since it hit the ground 7 seconds later, 7, 0 will be my other point. So 0, 0, and 7, 0 are my x-intercepts, since initial time is 0, initial height is 0, final time is 7, final height is 0. So those are my x-intercepts. Because x-intercept is 0, 0, I also know my y-intercept is 0, 0, but that's not particularly helpful in this case since we already are using it as an x-intercept. Again, like I was pointing out, we do not know our vertex because we do not know that this is the maximum height, so we'll just put a question mark there for now, since that's not going to be helpful. Last but not least, we know that other point I was talking about. It's not the vertex, but it is a key point. So a height of 2 feet, that means y is 2. After 1 second, that means x is 1. So x is our time, and in almost every problem we're going to encounter, x will represent time, or if time is involved, x will be time. So usually time is your independent variable, if that's helpful for figuring out how to write these coordinate points. So now that I know all of these key points, I'm going to think back to my forms of a quadratic. Which one would be most helpful? So again, vertex form is out, but I can do standard or factored. I know factored form because I know my x-intercepts, so I already know p and q, so I know 2 of the 3 pieces of information I need to write this equation. So I'm going to choose factored form because I know these x-intercepts, so I know p and q. I know 2 of the 3 bits of information right off the bat, so I'm going to use that form. So I'm using factored form. I'm substituting that information in, so I'll let you look at the rest of the problem. So I substitute the information in and simplify. So I plugged in 0 for P and 7 for Q, so 0 and 7. I took these values, plugged them in. And then I simplified it so that I don't need to write x minus 0, I could just write x. So I rewrote it in a simpler form. Then, as I pointed out, I had 2 of the 3 bits of information I needed, but I still needed to find a, and that's where our other point comes in. So you're always going to need at least 2 points or 3 points to, you're always going to need another point in order to solve for a. So I plugged in my 2 for y, my 1 for x, and then solved out for a. So I had 2 equals a times 1 minus 7, which became 2 equals a times negative 6. Divide both sides by negative 6. Sorry, I wrote it small over here, but I didn't want to leave room for the answer. A equals 2 over negative 6, or negative 1/3. Then I can write my final full equation, y equals negative 1/3 x times x minus 7. I have successfully written the equation for that quadratic. All right, so that's good for that example. We're going to do one quick check, and then I'll save the other problem I'd like to do together for our next set of notes because it's a little trickier. So I'm going to flip the page for our quick check. So this one, our quick check is: a diver dives from a 48-foot springboard and reaches a maximum height of 54 feet after 1 second. So I want you to write an equation that would model that situation or that trajectory of the diver. Try out on your own. I'm going to go over it in just a second. So again, just in case it's helpful, we know our time is x again, and our height is y. So if you're having trouble figuring out independent variable, if their time is involved, that will be your independent variable. Y is often the height in quadratic problems, but not always. Then let's go into our key points. So x-intercepts. Do I know any x-intercepts? I do not. So I don't know my x-intercepts because I don't know where it starts on the x-axis or when it has a height of 0, because it starts at 48 feet, so I don't know where it starts on the x-axis. But I do know my y-intercept for that same reason. I know my y-intercept would be 0, 48, which could be helpful. I also know my vertex. So I know my vertex this time because it tells me it's a maximum height, so I know that that tips me off that it's our vertex because it's a maximum or minimum. And it's going to be after 1 second, so x will be 1 and the height is 54, so y will be 54. So now I know I don't know another other coordinate. I don't know. So I don't know another point, but I have my vertex and my y-intercept, so I should have enough information to solve. So I'm going to, again, since I have my vertex, I'm going to choose vertex form. So I can say y equals ax minus 1 squared plus 54. So I've started my vertex form, but now I need to solve for a, so I need to plug in another value to do that. I luckily have my y-intercept, so I can plug in my y-intercept for x and y to solve for a. So I'm going to say 48 equals a times 0 minus 1 squared plus 54. So then 48 equals a times 1, because negative 1 squared is still 1, plus 54. I subtract 54 from both sides, and I get negative 6 is equal to a. So I subtracted 54, a is negative 6. So then I can write my full vertex form. So y equals negative 6 parentheses x minus 1 squared plus 54, and that is my answer. So this is the quadratic that would model that diver's trajectory. And that's all we have for today. So make sure you write down any questions, comments, or concerns you have so we can go over them together in class.